Good morning, dear students. My name is Ferhan Mazher, and today is 21st of April 2021. And right now, I am with the 11 Cambridge class. And today, we have set our hearts to solve May June 2003 paper 1. This paper is a paper of MCQs. We call it paper 1. So let's start. And 1 hour is allowed for this paper. So let's have a look at the first question. So the first question which is showing on your screen is the diagram shows part of a vernier scale. What is the reading on the vernier scale? You see, first of all, I will check the zero of the vernier has crossed how much on the main scale. So here we have the zero of the vernier scale. On the main scale, it has crossed 6.1, 6.2, 6.3, 6.4, 6.5. So 6.5 has been crossed. And so on a rough page, I will note down 6.5 and let me show you. Let me show you how I do this. On the, let me take out. Okay. So on the main scale, we have crossed 6.5, 6.5. So we have crossed 6.5. And in this, I will add the number of, I will check the vernier scale reading, which is coinciding with any line on the main scale. So you can see that here the fifth line is coinciding. The fifth line of the vernier scale is coinciding with the line on the main scale. So I will add in it plus 0.5. So the reading is
Sir, which paper is this?
the reading. So see, the reading was 6.5, and in it I will add 0.05. So the reading will be 6.55. Let me show you again. I think I made some mistake. The main scale reading was 6.5. In this, I will add the fifth line is matching. So I will write 0.05. So the 6.55 is the reading. 6.55 is the reading. So I think that question number 1B is the right answer. So let's check from the marking scheme. Oh yeah, the B is the right answer. So here we go. The B is the right answer. Okay. So now move to the next question. An object is falling under gravity. Which terminal with terminal velocity? What is happening to its speed? It is decreasing to a lower value. No, it is decreasing to zero. No, it is increasing. No, it is staying constant. At the terminal velocity, the velocity becomes constant. So I think D is the right answer. I think D is the right answer. So let's check the marking scheme. Yeah, question number 2, D is the right answer. Let's size. So question number 2, D is the right answer. Okay, so next question number 3 is on your screen. On the Earth, the gravitational field strength is 10 Newton per kg. On the Moon, the gravitational field strength is 1.6 Newton per kg. If an object has a weight of 50 Newton on Earth, what is its weight on the Moon? So let me show you this. Let me take out the. Okay, so here we have. So So on Earth, you see the weight is given. You know that W is equals to mg, and if you want to find out the value of the m, that will be equals to weight divided by g, and so that will be the weight. How much weight is given in the question? He says the weight on the Earth is 50 Newton. Okay, so the weight on the Earth is 50 Newton and the G value on the Earth is 10. So the mass of the thing is 5 kg. Now we will move to the on moon. On moon, the mass will remain the same. The mass will be the same. Mass do not change when you go to the moon. So the mass will be 5 kg, and the G value on the moon is different. That is 1.6 Newton per kg, Newton per kg. And now I want to find out the weight on the moon. The weight will be equals to mg. So mass is 5 kg, and the G value on the moon is 1.6. So by using the calculator, I can easily find out the value. Let me check if I have put the G value correctly. Yeah, that's correct. So I can find out, let me show you, uh, 5 multiply 1.6 and 8 Newton. So on the moon, the weight will be 8 Newton. So this is how you will solve this numerical. This is the answer, 8 Newton. So let me check the marking. Let me check what are the options. 8 Newton, C is the option. Question number 3, C is the option. Let's check the marking scheme. Question number 3, C is the right option. So our question number 3 is correct. So let's move to the next part. He says 10 identical steel balls, each of mass 27 gram, are immersed in a multi-cylinder containing the 20 centimeter cube of water. The reading of the water level rises to 50 centimeter cube. What is the density of the steel? Very simple question, and let me show you how I will do it. So take out a new one. Okay, this one. Okay. So the mass, there are 10 identical balls. Each ball is 27 grams. So my final answer will be 270 grams. The volume of these will be volume, because that will be the V2 minus the V1. So 50 minus, and let me check what was the volume. 20. So the V1 value was 20, the V2 value was 50. So 50 minus 20, and the volume is 30 centimeter cube. Now I know this, and I can find out the density. The density formula is the density is equals to mass divided by the volume. So I can find out this. Mass is 270 gram, and divided by the volume is 30. So I think the answer will be 0 cancel 9 grams per centimeter cube. It will be 9 grams per centimeter cube. 9 grams per centimeter cube. So I think C is the choice. Question number 4, C is the choice. So let's check the marking scheme. Question number 4, C is the right choice. Question number 4, C is the right choice. Okay. Question number 5 on your screen, an extension load graph is plotted to show the result of increasing the load on a spring. Which point marks the limit of proportionality? The limit of proportionality is that point up to which the graph is a straight line, and after that point, the graph becomes a curve. So that point is known as the limit of proportionality. If you look carefully, I think till B, the graph is a straight line, and after B, the graph has become a curve. So B is the limit of proportionality. B is the limit of proportionality. So question number 5, B is the answer, and our answer is right. Question number 5, B. Okay, so let's move to the next question. He says a person just support a mass of 20 kg suspended from a rope. What is the resultant force acting on the mass? Because you see, a person just supports a mass 20 kg suspended from a rope. So this mass is not moving upward, neither it's moving downward, it's just suspended there. So the resultant force on the mass is 0. The resultant force is 0 because this object is not moving. That's why the resultant force is 0. So I think A choice, question number 6, A choice. Let's check the mark. Marking scheme says A choice. That's so our answer is right. Let's move to the next question, and that question is question number 7. A driver's foot presses with a steady force of 20 Newton on a pedal in a car as shown. What is the force pulling on the piston? Okay. So here you have, whatever the turning effect or the moment produced here, same will be the moment produced here. Okay. So here the moment produced will be 20 multiply 40. Here the moment produced will be F multiply 5. And they both should be equal to each other. So 20 Newton multiply, let me do this and go. Okay. So the moment produced, so the force multiply the distance, and this means perpendicular distance, that should be equals to the force number 2 multiply the distance. And the force number 1, how much force you have applied. Let me check. 20 Newton, and the moment arm is 40 centimeter. 20 Newton force is applied and the moment arm is 40 centimeter. On the other side, the force is question and the moment arm is 5 centimeter. So if I will make the F alone, so that will be 20 multiply with the 40 and divided by with the 5. Let me do it on the calculator. So what I will get? So you will have 20 multiply with the 40 and you divide it with the 5. 160 Newton. 160 Newton. So 160 Newton. 160 Newton. D is the choice. Question number 7, D is the choice. Question number 7, D is the right choice. Okay, so let's move to the next question. Which of the following groups of physical quantities consist only of scalars? Only scalars. Acceleration. Acceleration is a vector. This is wrong. So B, acceleration. So this is not the only scalars. Force, time, velocity. Force is a vector quantity. So C cannot be the answer. D is mass, scalar, speed, scalar, time, scalar. So I think D is the answer. Question number 8, D is the right answer. Yeah, question number 8, D is the right answer. Okay, so we are moving to the next question. The question number 9 is showing on your screen. Which energy changes takes place when a paddling cyclist uses the generator dynamo to light his bicycle lamp? You see the paddles, he is paddling, so he has the chemical potential energy. That chemical potential energy is converted into the kinetic energy. That kinetic energy is converted through the dynamo into the electric energy. And the electric energy by the lamp is converted into the light energy. So chemical into kinetic into electric into light. So I think A is the right answer. Question number 9, A is the right answer. Question number 9, A is the right answer. Okay, so move to the next question. The next question is question number 10. A boy who weighs 50 Newton runs up a flight of stairs 6.5 meter high in 7 seconds. How much power does he develop? So, the power I can write here also. The power is equals to power will be equals to, and I can put a bracket here. So that's the work done divided by time, and that is weight, and multiply with the height, and that is 6.5, and that whole thing divided by divided by the time taken, that's 7. So the answer should be 50 multiplied 6.5 divided by 7. So I think C is the right, D is the right answer. Question number 10, D is the right answer. You can see I have written this answer here. So question number 10, D is the right answer, sir. Let's check. Question number 10, D is the right answer. Question number 10, D is the right answer. Okay, so now we are moving to the next question. Okay. The diagram shows a simple mercury barometer. Which height is a measurement of the atmospheric pressure? Remember this thing? This is from the level of the mercury in the tray to the level of the mercury in the inverted tube. So C is the right answer. Question number 11, C is the right answer. Question number 11, C is the right answer. It's easy peasy. Okay, so we move to next question. Here we go. He says, let me reduce the size so you can see the whole thing. Okay. Bubbles of gas escaping from the mud at the bottom of a deep lake rises to the surface. As the bubbles rise, they get larger. Why is this? The reason is when you go up, the pressure, the external pressure which is acting on the bubble, that is gradually decreasing. Because when you are rising upward, the water pressure will be gradually decreasing. So atmospheric pressure in the bubble decreases. No, the atmospheric pressure is not decreasing. Actually, the water pressure is decreasing. Water pressure on the bubble decreases because as you are going upward, you see, as you are moving upward, the level of the water, the depth of the water above the bubble is decreasing. So the pressure of the water is decreasing. Atmospheric pressure is constant. So because the water pressure is the pressure of the water is decreasing, and so it means the pressure which is acting from outside on the bubble, that is decreasing. That's why the volume of the bubble will be increasing. So C is the answer. Question number 12. I think C is the answer, and that is right. Question number 12, C is the right answer. Okay. A swimmer climbs out of a swimming pool on a warm day, warm, dry day. Almost immediately he begins to feel cold. Why is this? Because the water which is on his skin, that will evaporate. And when that will evaporate, it causes cooling. The water allows the convection current to remove heat from his skin. The water takes latent heat from his body in order to evaporate. That can be done. But if it has taken latent heat, it will start boiling. The water on his skin is a good conductor of heat. No, the water prevents infrared radiation from reaching his body. Okay, so now the good answer will be the water takes the latent heat from his body in order to evaporate. That can be the answer. The water allows the convection current to remove heat from his skin. No. So B is the best answer. The water takes latent heat from his body in order to evaporate. So I think B is the right answer. Question number 13. Let's check the marking scheme. So what the marking scheme has to say. Question number 13, B is the answer. So our answer is right. 13, B is the answer. Ice at minus 10 degrees centigrade is heated at a constant rate until it is water at 10 degrees centigrade. Which graph shows how the temperature changes with time? You see, then it's a heating curve. So the temperature of the water first will rise from minus 10 to 0. And then the graph will become flat because the ice will melt. And once the ice has melted, then the graph will again start rising upward. So first here, there should be an inclined line upward, and then the graph should become flat, and then again it should rise upward. So I think the B is the best answer. So very easy question. Question number 14, B is the right answer. Here the temperature of the ice is rising from minus 10 to 0. And so this flat graph shows that the ice is melting. Once the ice has melted, then again the temperature is rising from 0 to 10. So B is the right answer, right? Question number 14, B is the answer. So our answer is right. Question number 14, B is the right answer, sir. Okay, so we move to the next question. That's question number on your screen. A clinical thermometer is designed to respond quickly to a change in temperature and to have a high sensitivity. Which design features should the clinical thermometer have? So it is its bulb, its walls should be thin, very thin walls, and the bore should be narrow to make it more sensitive. So the walls of the bulb, or in which you have the mercury, that should be thin, and the bore should be narrow. So I think C is the right choice. C is the right choice. Question number 15. C is the right choice. Let's check. Okay, so our answer is right. C is the choice. A glass jug is designed so that it does not break when boiling water is poured onto it. What sort of glass should be used? You see, the glass which we should use, that should be thin. And why we use thin glass? Because the expansion inside and outside remains the same. If the expansion changes, the expansion which happening inside the glass and outside the jug, they are different, then the cracks will develop. So we want a thin glass so that the expansion outside and inside is same. So his question is, what sort of glass should we be used? The thickness, that should be thin, and expansion, it should expand a little bit when heated. There should be not very too much expansion. So I think D should be the answer. The glass should be thin and there should be little expansion when heated. D looks the right answer to me. Question number 16, but let's check the marking scheme. Okay, so D is the right answer, sir. D is the right answer. Which of the following is an example of a transverse and a longitudinal waves? You can see the light is the transverse wave, the water ripples, they are transverse waves, radio waves, they are transverse waves. The sound is a longitudinal. So sound is a longitudinal wave and the radio waves, they are transverse waves. I think that B is the right option. B is the right option, sir. Question number 17, let's check the marking scheme. Question number 17, B is the right answer. Okay, let's go to the next question. Here we go. So let's do size a bit. Still we cannot see. Okay. The diagram shows a water wave in the ripple tank. The wave has a speed of 12 centimeters at R. The wave crosses the boundary P2 where the distance between the crust changes from 3 centimeter to 1.5 centimeter. What is the velocity of the wave in the point S? Okay. So methodology is very simple. From this first portion, I will try to find out the frequency. So let's put it here. So in the first portion and this R portion, I will try to find out the frequency. You know, V is equals to F lambda. So if I want to find out the frequency, that will be equals to velocity and divided by the wavelength. The wave divided by the wavelength. Okay. So maybe the spellings are not right. Okay. Okay. So the velocity is 12 centimeter per second, and the wavelength here is 3. Yeah, 3. So the frequency here is 4 hertz. The frequency on the R side is 4 hertz. So now on this side, You know, when the water wave will come to this side, the frequency will not change. So I want to find out the velocity on this side. That will be frequency multiply with the wave wavelength. Wavelength. So that will the frequency will be the same. What was the frequency here? You know, the frequency here was 4 hertz. So the same frequency will be here. Frequency do not change. So that will be 4 and multiply with the wavelength here. That's 1.5. So when you multiply 4 with 1.5, I think it will be 6 centimeter per second. 6 centimeter per second. And that will be the speed here. So I hope that you have understood this numerical. First, from here, I know the wavelength, I know the speed. In this portion, I found the wavelength. I found the frequency. The same frequency will be on this side. So now I know the frequency here, I know the wavelength here. So very easily I can find the speed here. That's 6 centimeter per second. So the choice is B. The choice is B, question number 18. I think the B is the right option, sir. Yeah, question number 18, B is the right option. Here we go. A boy stands beside a girl in front of a large plane mirror. They are both at the same distance from the mirror as shown. Where does the boy see the girl's image? Okay. So let me increase the size so I can show you how. Okay. So let me first of all copy it from here. So I will show you how. Where does the boy see the girl's image? Show you how we will do this. So first of all, okay. So I will start a ray from the girl and that will go straight, pass through the lens. I will check. Do it another way. So I will start a ray from the girl directly to the. Okay. So I will measure how much is this distance. Okay. So I will take this. Try to understand what I've done. I have started a ray from the girl and it's making 90-degree angle with the glass and it went on to the other side. So the distance of the girl from the mirror, same distance on the other side. So wherever it stops, I will start a ray and I will take this ray to the eyes of the boy. Okay. So behind this is a virtual thing. Okay. So I joined that point with the eyes of the boy. And then I will start a ray from the eyes of the girl. Okay. This blue line. And then I will draw a normal here. I will check the angle of incidence. So the angle of incidence, and then I will check the angle of reflection. They should be equal. If they are equal, then where this red and this green line intersected, this point, here the image will be formed. So this is how I locate the image in the mirror. So the boy will be able to see the girl at the position A. It's a little, it took time, but you know the A is the answer. So question number 19, A is the right answer. So let's check the marking scheme. Question number 19, A is the right answer. So hopefully you have understood. Let's move to the next question. He says, question number 20. A ray of light is incident on one side of a rectangular glass block. Its path is plotted through the block and the out through another side. Which path is not possible? You see? So I have to take this whole thing and to show you exactly why something is rejected, why we have not taken a few things they are possible, few things which are not possible. So let me take this to the paint. Okay, so bear with me. Okay. So here the light is entering. So where the light entered into the glass block, it was supposed to bend towards the normal and it bended. So there's no problem. And I can show you here again. To draw these lines. So the normal is here. Okay. So you can see when the light entered from the glass block into the air, it was supposed to bend away from the normal, and it did. So there is no problem with the figure A. So now I'm going with the figure B. Okay. So in the figure E, the light entered into the glass block. So it is supposed to bend towards normal, and it did. Okay. So let's check here what happened. Here they have shown the process of total internal reflection. So the light has not gone out. The process of total internal reflection took place at this point. So it means that the angle of incidence here is more than the critical angle. Good. Okay, so that's because I'm working with the mouse, so it's a bit difficult. So now I will put a normal here. Now you see this angle of incidence here is clearly greater than this angle of incidence. The angle of incidence here is more than this angle of incidence. If this angle of incidence was more than the critical angle, this obviously is also greater than the critical angle. So the process of total internal reflection should have taken place here, but it has not. The light has gone out. So this is wrong. So basically, the B is the right option because, the path of the light here is incorrect. If here the process of total internal reflection took place, then it means this angle of incidence is more than the critical angle. then this angle of incidence is also more than the critical. Then why the light came out? Why the light emerges from the glass? Here the total internal reflection should have taken place. So this path of ray is wrong. If you want to check the others, you can check also. For example, if I check here, the light is coming out of the glass, so it should bend away from the normal. That is good. And here, when the light entered into the glass, it should bend towards the normal, and it bended towards the normal, so that is good. So C figure is clear. Actual answer is B. So here again, you can see when I put a normal here, the light was supposed to bend towards the normal, and it did, so this is good. Okay, so let's check what happened here. Oops. With the help of the mouse to draw these lines is a bit difficult. Here the process of total internal reflection has taken place. The angle of incidence is equals to the angle of reflection, so that's no problem. So this angle of incidence is more than the critical. Okay, now again, here the light has gone out. So let me put a normal here. So this angle of incidence is quite small, so the light should emerge. It's less than the critical angle, so light should go out. So D has no problems. Only the B figure has the problem, and we were looking for that ray which has a problem. Which ray path is not possible? So B. So B is not possible. B is not possible. So that was question number 20. Let's check the marking scheme. It took a lot of time. Question number 20, B is not possible. So B is the right option. Question number 20, B is the right option, sir. Okay, so we are moving to the next question. What is true for real images found by a converging lens? The real image found by the converging lens is inverted, and they can be captured on a screen. They are inverted, that is true. They are on the same side of the lens as the object, that's wrong. They can never be shown on a screen, that's wrong. The real images can be shown on a screen. They cannot be seen by the human eye, that is also wrong. So clearly question number 21A is the choice. Question number 21A is the choice. Let's check the marking scheme. Question number 21A is the choice. Okay, so let's move to the next question. Oof. Okay. Two sounds produced by two musical instruments are directed towards a microphone connected to an oscilloscope. The waveforms produced on the screen are shown. The waveforms show that the sound produced have a different property. What you see, if you look at these waves carefully, their amplitude. So I think this is the mean position. This goes one step upward and one step downward. So its amplitude is like 1. Its amplitude. So what's its mean position? Its amplitude is 2 steps up and kind of 1.5 down. So the mean position, if I suppose that the mean position is here, one very important, this wave is completed, you see, in how many squares? 1, 2, 2.5. So this wave is completed in 2.5 squares on the x-axis. And let's check how much this took. This wave also took 1, 2, 2.5. It also took like 2.5. So their time period is same. Their amplitude, their loudness is different, but in the options, the loudness is not mentioned. And their time period is same. If their time period is same, their frequency will be same. How do I know the time period same? Because the wave is completed in 2.5 squares on the x-axis. The same here. So the frequency says the frequency is same. Their wave, the waveform shows that the sound produced have a different property. What is the property? Frequency. Frequency is same, no doubt. Speed of the sound will be same. Timbre quality 100%. The timbre or the quality of the sound is different. Timbre means the basic shape of the wave. So the basic shape of the these waves, these sound waves is different from each other. So that's timbre quality. So that's different, 100% different. So wavelength, from this graph, I cannot say anything about the wavelength. From this graph, I cannot say anything about the wavelength because this is a displacement time graph on the CRO. So I think C, question number 2C is the option. Question number 22C is the option. Let's check. Maybe we are right. 22C is the right option, sir. Okay, let's move to the next question. The diagram shows part of a magnetic relay. M is part of the core of the magnet. L is part of the armature which is attracted to the core when a current flows through the coil. S is a stud which stops the armature being attracted too strongly. Which line of the table gives the best materials for M, L, and S? So M, that is the core of that coil, that should be of this iron, and L, that should be made of the iron. So it's a magnetic material and it is attracted to the magnet. S should be made of the copper because it's providing the path for the electricity. It's a connection for the electricity. So the L should be made of iron, I think, and the S should be made of the copper, and the M should be made of, I think, that iron because it's a core. I think it's core. And let's check. It's a little tricky. So we think that is B part, iron, copper. I'm not sure, but let's check. So question number 23, B choice. We are right. You can have a look. B is the answer for question number 23. Our logic was right. Okay. So which diagram correctly shows the electric field between two charged particles? So, the electric field lines from the positive, they come out, and in the negative, they go into the negative. So the A is directly wrong, clearly wrong, because from the negative, the electric field lines he's showing is coming out. That's wrong. B is right. From the positive charges, the electric field lines should be coming out, and they do not intersect each other, and they try to avoid each other. B looks the best answer. C is wrong because from negative, the electric field lines cannot come out. And D is also wrong because, the from the positive, the electric field lines are coming out, but they are going into the positive. That's wrong. So I think the best answer is B. B is the best answer. Let's check. Question number 24, B is the right answer. Okay, so let's move to the next part. An electrical quantity is defined as the energy converted by a source in driving a unit charge round a complete circle. What is the quantity? This is the definition of the EMF, electromotive force. An electric quantity is defined as the energy converted by a source in driving a unit charge around a complete circle. What is this quantity called? EMF. B is the choice. Question number 25. B is the choice. Question number 25. B is the right choice, sir. You can see that on the marking scheme. Okay, here we go. The diagram, I can increase the size a little bit. Okay. The diagram shows an electric circuit. Which pair of reading is obtained when a suitable power supply is connected between X and Y? Okay. So here you have been given four options. We know the resistance, and I can calculate the which pair of reading obtain a suitable power supply. That's right. Okay. So okay. So here we go. So for option A, I will calculate the amount of resistance. So let's check which one gives me the resistance. So you know the resistance is equals to V by I. V divided by I. So for all the options, I will calculate the resistance number 1. That will be equals to what is the voltage? 2 volt divided by the 6. So let's check what's the answer. So 2 divided by 6, that is not going to be okay. So you will have 2 divided by 6, answer is 0.33. So the answer is 0.33 ohm. Okay, let's calculate for the B option. That's R is equals to 2 divided by 0.5. And when you will do this on the calculator, it will be 4. That's not our answer. Okay, so the R is equals to now 12 divided by 0.5, and the answer will be 24. Yeah, this is the answer because our resistance has matched with that pair. Okay, so this is 12 divided by 2, and it will be how much? 6 ohm. That's not our answer. So the correct answer will be this one. So C is the right option. C is the right option, sir. C is the right option. Okay. C is the right option, sir. Okay, question number 27. The diagram shows part of an electric circuit. What is the current in the 2 ohm resistor? Okay. So I can find out the total resistance here, and I can find out the total resistance here, and then we'll see that how the current is. Let me do it on the paint. Start this. New. Don't save. Let me bring that question here. Try to understand our logic. So first of all, I will check what is the combined resistance. Okay, and that will be. Let me calculate that. They are connected in series. Let me call it R, and that will be equals to R1 plus R2 because they are connected in series with each other. So this will be 2 plus 8, and that will be equals to 10. So that will be the R1. Okay, and then what I will do, I will find out the resistance here. So let me check. Okay, then I will check out what is the resistance here. Okay, so let's see. So the upper branch is resistance is total resistance is 10. So the lower branch, let's see what's its resistance. So that they 5 and 5, they are connected in series with each other. So I will simply add them up. That will be also 10. So this upper branch, the total resistance is 10. The lower branch, that total resistance is 10. So this current which is coming from the battery, that's 6 ampere. So here both the branches, because both the branches have equal resistance, so the current will be equally divided. So the current which will flow through, the current which will flow from here, the current which will be flowing from here, the current which will be flowing from here, that will be, I think, 3. And the current which will be flowing from here, that will be also 3. So current will be equally divided because both the branches have the equivalent resistance. So the current flowing through the 2 ohm resistor will be 3 ampere. 3 ampere. Do we have this answer? C. So question number 27, clearly the C is the answer. Let's check. Oh, C is the right answer. Okay. So now move to the next part. Can increase the size, I think. Okay. An electric heater consists of a heating element mounted on a metal reflector. The reflector is connected to the earth. And where should the switch for the heating element be connected? The switch, the fuse, they are always connected in the live wire. Between the earth wire and the reflector, between the live wire and the heating element, yes. Between the live wire and the neutral wire, no. Between the neutral wire and the heating element, no. Between the live wire and the heating element, I think B is the right answer. Switches are always connected in the live wire, between the appliance and the live wire. So I picked the B choice, question number 28, and I think B is the right answer. Question number 28, B is the right answer. Okay, let's move to the next question. The next question is showing on your screen. We need to reduce the size a little bit so the whole thing can be shown. Okay, so almost now the whole thing. Each of the diagram below is a cross-section through 2 parallel current-carrying conductors. Which diagram correctly shows the magnetic field pattern around by the current in the 2 conductors? You see here the 2 conductors are shown. And in one conductor, they have put a dot, which means that the current is coming out of the screen. And in one conductor, they have put a cross, which means that the current is going into the screen. So if you use your right hand grip rule for the straight conductor, for example, I'm using my right hand rule to find out the dot, the conductor which is represented with the dot, the magnetic field around it should be in the clockwise manner. Sorry, I said clockwise. It should be anti-clockwise. My curves, when I look from here, they are anti-clockwise. So the conductor which is represented with the dot, which means that the current is coming out of the screen, I'm using this right hand rule, and the thumb is in the direction of the current, and this is showing that the magnetic field should be clockwise. Sorry, I said clockwise. It should anti-clockwise. So A cannot be the answer because they have shown clockwise. B cannot be the answer because they have shown here clockwise. C and D, the magnetic field shown around that dot is correct. It should be clockwise. Now for the other one, the current is going into the page. So the magnetic field should be clockwise. In the middle, the magnetic lines have the same direction. The magnetic lines have the same direction. So in the middle, the magnetic line should come very close. But outer side, the magnetic lines, they are in the opposite direction. So this D cannot be the answer, because outer side, you see, this is not possible that this goes and go around the other one, because its magnetic line direction and this magnetic line direction, they are not same. So this hugging thing cannot take place. So C is the choice. This hugging thing cannot happen, because you see this magnetic line, when it tried to go on around it, its magnetic lines are coming in the opposite direction. So that cannot happen. That hug cannot happen. So C is the right choice. Question number 29, C is the right choice. Let's check. Then we'll see. Question number 29, C is the right choice. A wire hangs between the poles of a magnet. When there is a current in the wire, in which direction does the wire move? Okay, so I will apply the left hand rule. I will apply the left hand rule. You know the left hand rule? This is the left hand rule. Stretch the fingers of the left hand in such a way. FMC. FMC. Thumb is force. Index finger is magnetic field. Middle finger is current. So the current is going downward. The magnetic field is from north to south. My thumb is pointing towards me. Current is downward. Magnetic field from north to south. My thumb is pointing towards me. I'm applying the Fleming's left hand rule. So it means A will be the direction. So it means A will be the direction. In which direction does the wire move? A. Question number 30. A is the choice. We have applied the Fleming's left hand rule in this. Okay, I hope you know this Fleming's left hand rule. Okay, now we are moving to the next question. What is the part of a simple DC motor that reverses the direction of current through the coil every half cycle? We call it commutator. We call it split ring commutator. So C is the choice. Without any doubt, C is the choice. Question number 31, C is the choice, sir. Question number 31, C is the choice. Okay, so let's move to the next part. The number of turns between each pair of the output terminal of a transformer is shown in the diagram. So on the primary side, I have 20 turns, and on the secondary side, I have choices. So if I take P and Q as the terminals, then there will be 10 turns. If I take P and R, then there will be 30 turns. If I take Q and R, there will be 20 turns. So you have multiple choices on the secondary side. Between which two terminals will the output be 12? The output should become double. The input is 6 volt. In the primary coil, the input voltage is 6 volt. And outside, on the secondary side, you want the V out to be, on the secondary voltage, you want to be 12. So the number of turns should become double. So the number of voltage, the output voltage you want double. So the number of turns also supposed to be double. So where should I put my connections? R and S. Because the number of turns are 40. Here in the primary coil, the number of turns are 20. So in the secondary, if you want the voltage to be doubled, the number of turns also should be doubled. So if there are 20 turns, there should be 40 turns. So R and S, R and S, R and S. Question number 32, R and S. C is the choice, I think. Question number 32, C is the right choice, sir. As you see, without solving anything, we have came to know the answer. And if you have understood the logic, I hope you have understood the logic. If you want to make the primary voltage, you want the secondary voltage to be double of that, like it was 6 volt, you want it to be 12 volt. The number of turns in the secondary should also be double the number of turns in the primary coil. So that's why we selected RS. C is the choice. Okay, the next question on showing on the screen. Why is electric energy usually transmitted by a high voltage? A very famous question on O-level physics. A very, very famous question. Because when you increase the voltage, the current reduces, and this reduces the power loss or energy loss in the transmission lines. So A is the choice. As little energy as possible is wasted in the transmission line. A is the right answer, sir. Question number 33. It's a very, very, very famous question. Frequently asked. Okay, so we are moving to the next part. Question is on the whole page. So try to understand this. The diagram shows a metal bar swinging like a pendulum across a uniform magnetic field. The motion induces an EMF between the ends of a bar. So here we have a bar, and this is the magnetic field. The magnetic field is shown by dots. Dots mean that the magnetic field is coming out of the screen. And when this bar will cut those magnetic lines, EMF will be induced. When it will go to the left, the EMF induced will have a different direction. When it will go to the right, it will have a different direction. The EMF induced will have a different direction. So this is a conductor which is cutting the magnetic line. So obviously the EMF will be induced. When this swings to the right, it will have a different EMF induced. When the direction of the EMF will be different. When it will swing to towards the left, the EMF induced will have a different direction. So which graph? So it's an alternating EMF will be induced. Which graph represents this EMF during one complete oscillation of the bar starting and finishing at P? So I think A is the best option. A is a complete wave of AC EMF, alternating EMF induced. A looks the best option to me. Question number 34. A is the option. Question number 34. A is the option. Okay, so now we are going to the next question, and here we go. Diagram 1 shows the oscilloscope trace produced by an input of 2 volt at 50 hertz. Diagram 2 shows the trace from a different input on the same oscilloscope. So its amplitude is 1. So its amplitude is 1. Its amplitude is also 1. 1 square, I mean 1 division, it went up. So so the both of them have the same voltage. The voltage is same. Here in 1, 2, 3, 4, in the 4 squares, 1 wave is shown. And here in the 4 squares, 2 waves are shown. So it means its frequency is more. It means its frequency is higher. Its frequency is double. Here in 4 squares, 1 wave was shown, and its frequency they were saying is 50 hertz. And here in the 4 squares, now we have 2 waves. It means that its frequency is double the frequency of the previous wave. Its frequency was 50 hertz, so its frequency will be double, 100. So I think C is the right answer, sir. Question number 35, C will be the right answer. Let's check. Question number 35, C is supposed to be the right answer. So I hope that you have understood. Question number 35, C is the right answer. You see, this was on the whole page, so I was not able to show it more clearly. Okay, now we can increase the size. So this is question number. The electric circuit shown is used to study the charging of the capacitor C. So this capacitor is being charged. The neon lamp lights when the potential difference across the capacitor reaches 110 volt. The capacitor C then discharges, the lamp goes out, and the potential difference across the C slowly increases once more. What is the effect of increasing the resistance R? If you will increase the resistance R here, it will take higher voltage. When it will take higher voltage, the voltage provided to the capacitor and the neon lamp, will be reduced, and so the capacitor will take a longer time to charge up. So the frequency of the neon lamp switching on and off, that will decrease. So the lamp lights up. What is the fact of increasing the resistance of R? The lamp lights up and goes out at the same rate? No. The lamp lights up and goes out less frequently. Yes. That's the thing. So I think B is the choice. Question number 36, B is the right choice. Question number 36, B is the right choice. This question was about the capacitors. So our students have always a little issue with the capacitors. In a fission reactor, which particle causes a uranium-235 nucleus to split? You see, we take a neutron and we bombard the uranium with a neutron. That's the diagram which is in your textbook. We take a uranium nucleus, we bombard a neutron on the nucleus, and it's broken. So neutron, we use a neutron, and 3 neutrons are produced. This is a fission reaction which happens in the nuclear reactor. So C is the choice. Question number 37. C is the choice. It's a fact and which you should remember. A neutron is used in the fission in the reactor. A radioactive isotope has a half-life of 2 minutes. Sorry. A radioactive isotope has a half-life of 2 minutes. What can be deduced from this statement? After 1 and 2 minutes, 1/4 of the isotopes remain. After 1 minute, 1/4 of the isotopes remain. After 4 minutes, this is something logical. After 4 minutes, 1/4 of the isotopes remain. Okay, let me show you. See, okay. So if when 1 half-life will pass, suppose this is n. So after 1 half-life, it will become n by to write 2 is very difficult. So that we write 2. Okay. Another half-life will pass and it will become n by. I just want to show you the right answer there. N by 4. Another will pass by and it will become n by 8. So when 2 half-lives, every half-life is of 2 minutes. So 2 half-lives means 4 minutes. So after 4 minutes, the sample, how much sample will be left? N by 4, 1/4 of the original. So after 2 half-lives, which means 4 minutes, 1/4 of the original will be left. So that is the answer. So I think after 4 minutes, 1/4 of the isotope remains. So question number 38, C is the right answer, sir. Yeah, C is the right answer. Okay. The diagram shows how the thickness of paper is measured during the manufacture. If the sheet is too thick, fewer beta particles can reach the detector. Okay. So we are using a source of beta particles. A source of alpha particle is not used for this purpose because the alpha particles, they are stopped by the paper. They cannot penetrate through the paper. So we cannot use alpha particles here because they cannot penetrate through the paper. So because they are all start by the paper. That's right. Question number 39. A is the choice. Yes. Question number 39. A is the right choice. So then we have question number 40 coming on your screen. The result of the Geiger-Marchson scattering experiment provided evidence for the presence of the nucleus within the atom. What were scattered in this experiment? So what they have done, they have taken, I think, the alpha particles, and they have bombarded a gold foil with the alpha particles. And you know, the most of the alpha particles went straight. Very few were scattered at a larger angle, and very few were bounced back. So they used alpha particles. You must have studied this experiment in your physics. You must have studied this experiment in your chemistry. This is the discovery of the nucleus of the atom. So we use alpha particles in the scattering experiment done by the Geiger and Marchson experiment, in which they found the nucleus of the atom. So I think A is the choice. Yeah, question number 40, A is the right choice. So, my dear students, and I have we have reached the today. Let me come back to the first page so I can show you. Okay, today we have done May June 2003 paper 1, and I hope that this session has been helpful to you. You must have understand few new concepts of the physics, and or the new concepts, your previous concepts have been polished. If this video is helpful to you, don't forget to subscribe to my YouTube channel and recommend these videos to your class fellows, to your friends, so they can also watch these videos and they can solve the MCQs and theory papers through the YouTube. So I hope that this is very helpful to you. I'm trying my best to do this. Don't forget to subscribe to my channel. So thank you very much, my dear students, and have a good day. And God bless you all. And bye bye.